I'm Danielle Peterson from Infrastructure News. Today for CPD On Demand, we are talking to private consulting engineer Eduard Kleyn about G1 crushed stone. Thank you so much for joining us. Now, G1 crushed stone is a South African development. So can you tell us about the history of it and how it came about?
Yeah, rather a very proud development which nobody seems to be able to follow in the rest of the world, although they recognize the quality of it. We started late 1950s when I got involved in it, and we had something then called crusher run, and that was used all over the world for base course, and it was just some crushed rock produced by a crusher without any specification. But we noticed that after some typical high-fell storms and the like, sorry, I am missing my beat there. It dawned on us that the rain was not really harming or damaging the layer of crushed rock that we put down. In fact, if you continue to compact while it is raining, it tends to have deliver a better product. It is like you have a stronger layer, and we couldn't quite understand that at that time, and said, well, we better investigate this. There's something is happening here which makes this layer react better to the compaction. And to shorten it now, the story, we found out that if you compact the material and you also have water on it like rain, it tends to bring the fines to the surface and expel it as the compactor is running over the material, and it is slotting together the larger aggregate. The fines are being expelled, and it is necessary to have a lot of water then, and you actually in a way wash it out of the layer, and you do that until nothing comes. Well, you finish all the fines. The fines has now been extracted, and you only have the larger rock making contact with the other pieces of rock or stone around it. And we developed a method whereby you do it on purpose, and we call it slush compaction. So G1 is an exceptional material, the only type of material that you slush compact to get it to interlock. You can do the normal compaction. You get, say, for instance, a lower grade, say G3 or something like that, but once you get to G2 and G1, it means you have to slush compact it to get that specific interlock. So we're very proud to have developed that, because we have had other country representatives here, and they couldn't really understand how our pavements could develop that strength until we showed them what we do, and they said, but that is too simple, that cannot be. And we said, well, that is exactly how we do it. If you want to stand by, we will show you how we do it. And so a lot of interest started being developed overseas and all over, but it seems like they still have a problem about the simplicity. They think there should be much more involved in getting the strengths we do get, because we then could also do something which other countries cannot all do, and that is use the heavy vehicle simulator on these pavements. And I am not going to explain that now. I think we we take it that people understand what a heavy vehicle simulator is, and we could test those pavements and find out that their bearing capacity increases tremendously when you slush compact it. Something that even surprised us, but we got over that and we started being proud of being able to achieve that. And it is, well, something the overseas guys still come over and discuss with us and tell us, no, it's too much work and it's too expensive, and say, well, what we get is so good that we think it's worth the cost to do that. And now the specification is that way for G1, that you will compact it with a slush action.
Okay, so now that you've kind of given us the overview and the understanding, how exactly do you define G1 crushed stone?
Well, it's interesting. It's a layer. The name G1 crushed stone, we decided that that will be the name of a layer that was done to the exacting standard that I've more or less described to you now. So it is crushed rock which is done to a continuous grading. Now that's very important. The material has to have a continuous grading from 37.5 millimeter down to dust. And it is that grading which is such that all particles can interlock once you extract the dust or the minus 0.75 millimeter from it, so that the larger particles interlock. And so a G1 crushed stone is that kind of layer which has a continuous grading of material, slush compacted and interlocked to refusal. Now this slush compaction, in other words, has to continue until no movement is visible under any rollers. Nothing happens, no fines are coming out anymore. So only then are you finished doing your slush compaction, and the material then reacts as if a single piece of aggregate. It is so tightly interlocked that it reacts like a single piece of interlock, to the point of being able to be in sync with the load. Now that is maybe something strange to say, but in other words, it means that the layer, as we call it in pot market terms, makes muscle to the extent that you load it. It has a certain strength that you can measure when there's no load on it. The moment you put a load on it, it starts behaving differently, like a solid piece of rock would. The more you load it, the more it handles that load, and it reacts back. Now that is the only material, or shall I say pavement layer in the world that will do that, and which is why we're very proud. We developed it here. We now know how to do it. We now know it works if you build it properly. Now, true, maybe you have to do it properly. It's not difficult. It is just something that you really have to do all the parts of sort of in succession, succinctly. And that is one thing I think overseas countries maybe have a problem with, because they like fast flow. Everything must be fast. And so they don't take the time to interlock the particles properly. And so they don't get a layer that has that reaction to load.
We've touched on it now, you have touched on it, but can you explain to us the main attributes then of G1 crushed stone?
Well, mainly the main one is that it's linearly elastic. Now that means, again, I've explained a bit of it, but when you have a loose layer of material like aggregate and so on, and you compact it, it deforms as you compact it. Once you have slush compacted it and it's interlocked, it does not deform anymore. So, provided, of course, you know, supporting it properly, which is very important. That is important that you have that kind of support. But then you have a material that, as we say, makes muscle as you load it. In other words, it will push back as much as you load it, and it will not deform. Where normal gravel layers, as you load it, it will compact and deform. The way we do G1 is such that we take that liability out of it. Now we remove it from the composition or from the setup, so that you now know whatever you load, your load is, this layer will stay there and it will handle that, and it makes it a very, very special layer of material which is only to be found here in South Africa. And yes, there are differences of opinion. Even in South Africa, some road authorities do it a little this way and others do it a little that way. But basically, it boils down to the same thing of slush compacting it to interlock it such that there's no movement when you put a heavier load on it, or you the load changes. For instance, the traffic now becomes heavier. You don't have to do anything to the layer that is there. It's already ready, rock on rock, interlocked, and it just sits there and handles that load that you impose on it.
Now, you touched on it briefly now when you spoke about the base.
Yeah.
So how important is your sub-base layer, and what do you need to ensure that that is to have a correct G1 crushed stone layer?
Now, very important. I'm glad you mentioned that, because obviously nothing sits in thin air. So that means that you have to build the pavement up layer by layers, you know, as normal, sort of going stronger, stronger, stronger to the top where you have the strongest layer. But in this case, G1 crushed stone is a slightly different animal in the sense that it cannot tolerate movement. So your support of it must be very good, so that you can interlock it, and then whatever load you put on it, it stays interlocked and it does not move, because then it will de-densify. So now that means that you build it up to a point where your sub-base is stabilized or cemented. Now that is maybe 2 or 3-fold. It has to be impervious to water, because you are going to slush compact this layer on top of it with lots of water. Now you need it to be impervious to that, well, in more ways than one. And then you need to see to it that the crushed stone base on top of it has nowhere to go to. No, if you load it, it cannot go down. It is supported properly from below, so that once you have it interlocked, it cannot move, it cannot deflect, or rather that. So that is very, very important, that you have that kind of support value. If you don't have it, and you have a layer that can move around or heave or deflect and so on, actually deform. Deflect is not the right word. Deform is the better word, because deflect it will anyhow deflect but not deform, and that is important. It will not densify. That's what we want. So you need to have that layer, subbase, impervious to water, sitting there without falling apart. If you now put a load on it, it must be able to handle lots of water. It must be an anvil on which you can really compact the G1 so that you get the G1 crushed stone on top of it. So that is a very important aspect of it. You cannot build it without having that kind of support.
And when it comes to the material used, how does that differ from crusher run, and how important is it to select quality material?
Well, it is funny that you should ask me, how does it differ from crusher run? It doesn't really differ from it, except that you need a continuous grading. You want the material to be graded continuously from the largest particles, which in this case is 37.5 millimeters, down to powder. You want that kind of grading in it, and the quality of the rock itself is closely monitored, because some crushed rock is not hard enough. Now, if you're going to slush compact it, it must have a good hardness, otherwise you're going to crush that rock itself. And in other words, I mean, I've seen that with people using qualified person might use any kind of soft sandstone or something like that. The sandstone that I've seen people use have a tendency to break down continuously, and you lose your layer actually. It is being crushed to sand, you broom it off, and you continue with the compaction, and the same thing happens. So certain rock, and that is specified in the specifications, what type of material you may use.
When it comes to selecting the material, how does the material for G1 differ from other materials, and how important is it to select a very good quality material?
Well, it's very important. I'm glad you asked that, because since you're going to give it all the energy you can to interlock it, it better be strong so that you don't shatter it, or it doesn't shatter. There are certain aggregates, or shall I say rocks, that will disintegrate under that kind of handling and compaction. Like sandstone you cannot use, it's usually too soft, but there are other, like dolerite can be used for that, but it has other niggling that people try and avoid with dolerite for. It can have a plasticity index that's troublesome, and you have to be prepared to handle that. Say for instance by adding some lime and trying to curb the disintegration or the chemical disintegration of that material. But the other attributes, like you don't want any mica in it, and you get certain aggregates like granites which can contain mica, and that you don't want, because mica is a platelet type of thing which absorbs water and expands, and so if it rains on it, or if it's then dry again after the rain, it contracts and it expands and it contracts as it absorbs water and loses the water, which disrupts the integrity of the layer. So you must have very good quality hard rock without any contaminants such as mica or any other detrimental material that goes soft when you wet it up, or that will soak up water. So yes, you have to find the right, you've got to prospect for it, get the right material with the right hardness and the right qualities of mineralogy and that type of thing, so that it does not dissolve, for instance, or break down too fast. So for that reason, you do need to select good quality rock, that is for sure. You cannot use any old rock, and especially not soft rock, and rock that contains detrimental kind of materials there, that will decompose to clayish type of material quickly. And that can happen if you don't watch it.
Okay, can you then talk us through the process that you follow when constructing a G1 crushed stone layer?
How long have you got? This again, I have to say, one must realize it is not rocket science. It is just something you've got to do step by step precisely, and you will get the end result that you're looking for. But I don't know why people are so scared of doing it. You need, of course, first of all, the quality material from a quarry. That is crushed to continuous grading. Now, I try and warn people, say, when you buy the material, when you get it from a crusher, or you intend getting it from a crusher, watch it that the person, the crusher can deliver exactly that. So you have to check all aspects of his plant crushing process, the works, to make sure that he can deliver that specification. And before you buy from him, if you don't do that, you can land yourself with a material that you cannot slush compact. And hence you cannot get the interlock and the strength. Now I have to stress it seems like you've got to stress it each time you talk to people. Somehow they forget that this thing has to be slush compact. That takes a lot of energy, a lot of water, and if there's anything wrong with the material you've got, you will not get the end result. And the one thing for sure is your grading. It must be continuous all the way from 37.5 to dust or minus 0.75 millimeter material. Just the physical aspect of it. Never mind then what type of material it is. So you have then, if you're satisfied that that quarry can deliver it, well then you get a sort of a small quantity, because you are going to build a test section. That is specified in your specifications. Your Koto or Koto now, the specifications tells you to build a test section so that you can see that you can build it. The material is okay to build with. The quarry can deliver that amount, the type. So you make quite sure through a test section that it is possible before you say deliver tons and tons of it. So then you now get it delivered on site, and as they deliver it, you do tests all the way through to make sure the quality, everything is right, so that when you start taking it from to dump on the road, the next step, from your stockpile where you have now put the material down on your site, you have to take it to the road and dump it there on the road, along the road in heaps that you can then flatten to make the layer that you want from. But before you do that, you have to dampen this material that you have on the road if it's not damp already. And it doesn't mean you wash it, because you wash the fines out if you do too much water. You only want to dampen it because this G1 material is very prone to segregation if it's just dry.
Okay.
The wind will blow some away, the rain will wash the fines away. So once you've dumped it there on the road, you then flatten the heap slightly, just slightly, so that the water cart can drive over it. And then you spray water on it to dampen it, not to soak it or to really wet it. And that people must understand. It's very important, because if you do that, you wash the fines out under, it runs out from these heaps or these dumps, and you cannot slush compact it afterwards because your fines are gone. So that is very, very important. So you dampen it, you push it with a grader, push the heaps sort of like to not really in a layer, but just so that the water cart can drive over it slowly and dampen it. Thereafter, you start spreading it. You make a layer of it. And now, once you've got it there, you now have a look and see, has it got enough water? Because you want to get it to optimum moisture content to make the layer, to sort of mix the material properly, because you want it mixed properly so that it is one uniform layer of aggregate. And then you want it at the right moisture content so that you can start compacting it. Now, so once you've got that, and it's now at optimum moisture content, and you've got a nice sausage of a layer here, but it's not compacted yet. So now you start compacting that layer with a heavy roller. And that is also very important. Not a tennis court roller. And I know I'm saying that jokingly. People will use a 10-ton roller, and even sometimes a 12-ton is too light. You need to have something like a 17, 18-ton roller if you want to do it really properly. If you have too light a roller and you attempt to compact it, it will take up too much, shall I say, rolling. And you roll and roll and roll and you won't get the type of compaction that you need that you need to have before you slush compact it. Now, you need to then have a vibratory roller. You can also have a flat, but those two are very important that you need on the side. And a vibratory usually has a set of pneumatic tires on one end and the vibratory drum on the other side. That's fine. That's excellent. You use that. And you need to do the compaction as you would any other layer. There's nothing different from what you're doing now. It's just plain compaction of the layer to a specific density, which is more or less the same thing as you would with any other layer. And then you do that up to a point where it is interlocked enough, sufficiently, but not the final product, but just sufficiently that you can now start the slush compaction. You cannot start the slush compaction below a certain density because it takes a lot of water. And if it's not already interlocked to a certain extent, it will just run away, the layer will deform, and it won't compact anymore. So we warn people and say, you're going to get it to at least 84, 85% of apparent relative density. And that people must understand there's a reason for it. Before you can start slush compacting it. Otherwise it will deform, it will shove around and that type of thing. So now you have it at 84% of apparent relative density, and you can now start your slushing action. So you now bring in the water card, spray a lot of water, and have one or two rollers right behind the water card, really right behind it. And so you spray the water whilst the rollers, if you have two fine, run behind it. Now, this, I have to stress this, and I've got to avoid using pot market terms too much because some of them are called swear words. So you must not overuse the vibratory action. Actually, as little as possible. So when you first start compacting this layer of a material and it's already sort of nicely shaped and it's ready there, you put it down and you compact it normally, but only 1 or 2 to 3 passes with vibratory rolling. Otherwise you will start crushing the material, so don't overdo it. Because the slushing action does not need vibratory rolling. Yeah. So don't think you need the vibratory roller for the slushing action. You can, depending on what it looks like to you, what it feels like, the density, have you got 84 for apparent and so, you might want to put 1 pass of vibratory rolling on it, but not more than 3. And very definitely not more than 3, because a vibratory roller has a specific action which people seem to forget. It compacts up to the maximum for that roller. Thereafter, when you continue with the vibratory rolling, it decompacts. So in other words, you get if you continue rolling with a vibratory roller, it will take the density up, take it down, take it up and down, and each time to a lesser degree than the first time. So you have to stop soon enough, otherwise you lose the density that or the interlock that you've put in the first time. So now, when you have it at the right thing, density about 84, 85, everything is, it feels right, it looks right, you've measured the density with whatever instrument you're using. Now you put the water on it, and you have the 2 rollers without vibration running behind this water card. And this, it is important to do. It's at speed. People don't seem to understand. You want to suck out the fines, basically, from, can call it that, I know it's maybe exaggerating. You want to compact it such that it pushes the fines to the surface. But also, when you do it at quite a speed, you will find, and you can see it on the drums of the roller, that it has a tendency to suck also, because the fines that come out are sort of creamy. It's a creamy material. It is not a sandy material. So that is very important. Some people think that when they slush compact it, and it must look sandy. It is not a sandy material. The -0.75 millimeter is something that has a creamy substance. And you need to do that slush compaction at about 10 kilometers an hour. That is quite fast. You might be able to run along it. You cannot walk along it, it's too fast for that. But it helps to get the action done rather quickly. It helps with the sucking as well as the compaction of the material. And you will see, once you started that action and the fines are coming out, you will see bubbles, air bubbles. As you compact the material and it's being interlocked, it forces the air out that is still in the layer, and it comes up to the surface, and you will see it, sometimes a lot, sometimes just a bubble here and a bubble there. And you will see the fines also coming through, the creamy fines. Now, you have to continue that action until no more fines are coming out, until the water basically clears, because this fines has a tendency to color the water, to the color of the material. When there's nothing coming out and you have now swept or brushed it off the surface of the layer as you continue, because you also have to do that as the fines come up. You don't want more than about 5 to 7 millimeter layer of it, because it inhibits the slush action. And so you broom it off and you continue the watering, and with the watering cart, and running behind, close behind it with your rollers. And once you see there's no more, well, movement for sure of the layer, the slushing has stopped. It's just more or less clear water that you're brushing off. Then you know this is now the end product. You stop there. You measure the density. You want 88% of apparent relative density at that point. That's usually the specified density. Although I shy away from using the word density, I say look with your eyes to see that you have interlocked the aggregate. You can see that. You will see a mosaic. It is not just compacting it and then you have density. You will see the larger aggregate forming a mosaic on top. And that's the thing that you need. That's what gives you the strength, the support value that you're looking for. So you must watch for that as you do the process. You can, and therefore, please, you cannot just have a few roller drivers going up and down the road. You need a person there who knows what he's looking at and will know what to do, bring in more water, stop the rolling for a moment, take off, for instance, the steel drum and just keep the pneumatic roller there, because if you overdo it with a steel drum, you crush the rock at the top. In other words, the larger stone which should form the mosaic is being crushed, and then the contractor sweeps it off, and so he continues, and it is to no avail. So all these things need to be watched. As I say, it's not rocket science. It's just you've got to know what you're looking at and do it succinctly, you know, the process. And listen to sounds of, are you crushing the material? Look at what's happening to the larger particles. Are they breaking down? If that is starting to happen, then take the steel drum off and use the pneumatic only, and do the final slush compaction only with a pneumatic roller. So these little things are important, and that's why you need an experienced person to stand there when they're doing the slush compaction. So when you think it's finished, check now your density, since that's the only way at the moment still that you can do it. There are also other methods, but this is a specified method now in the specifications. Check that you have the 88 at least of apparent relative density, and then you can say, okay, this is where I stop. Now the layer is finished, and you leave it to dry out for a day more or less. Just leave it, and then you broom it lightly. I mean, when you broom the slush off, it's still a light action. You are not trying to dislodge the large aggregate. You're just touching the aggregate and getting the slush off. And once the layer has now dried for a day or so, you also broom it lightly to get the fines off that is lying over basically the larger aggregate. Is sort of, you can just see it's just a thin layer of sand or maybe slush still on it, and you get that off, and then you see really properly the mosaic. Once you've got that done, you see there's the mosaic. And then the final thing you do, once you've got it, your mosaic very visible and open to the naked eye, then you give the whole entire layer a once over roll with a pneumatic roller. That is to flatten any aggregate that still maybe has a tendency to stand proud, because it can happen that it has some water under it, and that water has to evaporate. Now that the water is gone, and you drive over it with a one-pass pneumatic compaction, it sort of just pushes the larger aggregate down nicely to knit into the layer, and then you leave it, then it's finished. And you will see it has a mosaic, a very distinct mosaic of larger particles with some fines in between, but that close knit sort of mosaic. And that is what you actually want. So if you know what you're aiming for and watch for it, there's no problem in achieving it. I mean, nothing that I've described here should frighten any contractor. It's actually too simple. It's when you do something else and you try to be very forceful with it. There's no need for that. Just roll the stuff, broom it lightly, get the water on it. The whole cycle is a gentle cycle. It's not forcing anything.
Now you've touched on it, such as the issues with compaction. But what are some of the common mistakes that you see people making?
Yeah, well, I shouldn't talk about it too much. It brings tears to my eyes, because it's actually a simple process that can, I can't believe can be so difficult to just execute. Now, things that, I mean, I see, first thing that I mention to people, or when I talk about the G1, is you have to have the right specification. You have to buy the right stuff. And still, it happens that you get onto site and people haven't got material that's in spec. Now you don't. You have all these expensive machines around you. You can't build it, although they try, with material that's out of spec, and there's no way you can make a G1 crushed stone from it. But you tell people that, and they get very upset with you, and they will sometimes still try to get it unsuccessfully. So what must you do? I have to then walk away from that, because I mean it's that person's money, his machines, and he is now going to do it his way.
You have touched on it a bit in what you've been speaking about, but can you run us through some of the common mistakes that you see contractors making on site?
Well, yes, not my favorite topic, but I'm forced to say something about it repeatedly. One, of course, is the thing that we started off with. And you must have the material that is in spec. You know what the spec is, you can read it. That's what you buy. You don't buy something from a crusher that is not in spec, because I don't know if a contractor realizes that makes him pay twice for the material, because he pays the contractor for the material. It is not in spec. He cannot then deliver the product, or he has a very difficult time, spends a lot of hours and on the material. That's when he pays the second time. So now he's got a very expensive material there, which is not what it's supposed to be. So I tell people, that is number one. You don't have to worry. If you don't have material that's in spec, it doesn't matter what else you have. You can't start. Okay, then the next thing is, when your site is not prepared, when your road is not prepared, you don't have a good anvil to put the G1 crushed stone to achieve it on. So in other words, you need a stable, water-resistive anvil, stabilized with cement really well, so that it gives you a very good surface, smooth and stable, so that when you move the material around on it, the G1, your blade, your grader blade does not disrupt the subbase. It is a smooth plane on which to move your G1 material on. So that is very important to have that. That's one of those first two things. Is like you don't start when you don't have it. Now, the other thing which one would not think possible is misapplication of equipment. When a person does not know what a roller is capable of. For instance, if I say an 18-ton roller, that does, and you need that, it is not equivalent to 2 extra passes or whatever many of a 10-ton roller. A 10-ton roller can exert that kind of energy, and not more. And it doesn't matter how much longer you roll, it still just has that kind of energy. So don't think, if you don't have the appropriate roller, the 18-tonner or the 12-tonner, the 17-tonner, you can now double your 10-tonner. It's not going to work. You need that energy to push it together. So that I have to continuously warn people about. Very important that you have trained operators, not just drivers. You need an operator who knows his machine, who can hear when something is happening, who knows what to do then. So it is an important point that you have an operator that's trained. Now, it's as strange as it might sound, you still get contractors who tell me the slush compaction is not necessary. They get just as good results without it as with it. Now, that is not true. There's no way you can get the kind of support value, the interlock, without the slush action, without extracting the excess fines that you have to extract from the layer, so that you can move the larger particles together to get rock on rock. The next thing is, you do need to work at optimum moisture content. You cannot do the compaction below that moisture content or far above it. I have been on site where you walk in on a layer and you sink into it up to your ankles virtually because it's so wet. That is not the right way to go. And so then I get told, well, you leave it to dry out and then it'll be right. Yeah, you leave it to dry out, but then you still have to carry out the proper slush compaction action at the OMC of that material. Those things are maybe small things, but they can make or break the layer. So let me then mention lack of supervision. I've seen a lonely roller operator sitting on a site, on a section, running up and down nearly all day, trying to get it right. Has nobody to advise him, nobody to guide him, nothing. So I arrive on site because I've heard that they have a problem, and he is virtually crying on my shoulder because he's so lonely. Now I can stand with him and say, okay, now do that, now do that, now do that. Water this thing, whatever needs to be done. And suddenly he is now much more trained also, happy that he could achieve the end product, but not before he wasted lots of dieseline and crushed the top of the layer such that he had to broom about a quarter of the layer away and formed a windrow next to the road of fine aggregate, or actually I tease them on it and say, so you want to go into competition with the crushers. You also now want to make sand. Leave it to them. They will make the sand and they will make the other aggregates. Don't you do it. You have to just compact it and interlock it.
So Edward, now when is G1 crushed stone specified?
Well, that is when you really need to carry heavy traffic, when you want a top-notch quality pavement, bearing capacity wise, as well as the ability to handle extra loading which it wasn't designed for instance. As I said, it's one of the main things of a G1 crushed stone. It can make muscle. It can adapt to load increase. If it's built properly, it will adapt to whatever load up to the point where the load is so heavy that it will shatter the aggregate. Now that is not easy to do if you have the right type of aggregate. So that is the type of animal you have there, that you can load, and it doesn't matter whether it is overloaded or it is this. And people don't realize that the gravel or asphalt does not do that. It will feel the overload and it will fail far easier than a G1 crushed stone pavement that is built properly, because of the fact that it makes muscle, it increases its support when the load increases. Now that's a very special thing. There's no other material, no other pavement that will do that. And it is important, I think I must mention it here, the overseas people who were here thought they were very clever to say, oh, this type of pavement that we now have here in South Africa, and you know, some people don't like that we could do something so good, so well, so special. They said we have an upside down pavement, because they do not realize this fact that it will make muscle to the extent that it's loaded. So when it's in rest, it's pavement, The G1 crushed stone which lies there is not, doesn't have to do any supporting. So it's relaxed. And the strength it shows when you measure it at that level, when it's doing no work, is very low, shall I say. Much lower than you'd find for asphalt and stabilized layers and so forth. And we had to explain to them, you're quite right. It might sound like an upside down pavement to you, because you see the top layer, which should be the strongest, as the weakest now. But it's in rest. Once you load it, it makes muscle and it goes to where it needs to go, and strength, which is something very, very special. There is no other pavement that will do that. So we're very proud of that. So I stress that point, and I say it as a sort of proudly South African. We developed it. We got something that is the Rolls Royce. And not only that, it's adaptable to any load you can put it on it. So I tell people, build it with pride, build it correctly.
Well, Edward, thank you so much. That has been really interesting. Thank you for your time. This has been CPD On Demand.